Labas vakaras. Hello everybody who gathered here today live. Hello to our viewers online. Thank you for coming to our .NET conference. So it's organized by our .NET Pro community together with our partner Microsoft. Probably you already know, so Microsoft a couple of weeks ago released .NET 8. Also a lot of interesting stuff together with it. So today we have 3 presenters and we will present 3 different topics. We would like to take a look in depth more in what Microsoft presented. So we have first Andrew. He will talk a bit about the .NET 8 and the C# 12 features. The next one will be Alexei. Alexei will introduce ASP.NET Core, what improved. And last will be Gintautas. He will present about open telemetry in .NET. Meanwhile, please grab some snacks, take some stickers, please take a cup as a reminder for yourself. And we will have some time after each speaker finishes for some question session, so please be active. Thank you. Andrew, word to you.
Okay. Can you hear me? Yeah. Okay. So let's start. I'm Andrew Zabirka. I'm initially from Belarus. Now I'm here presenting you what Microsoft prepared for us. I'm a lead software engineer here at EPAM, and at the same time I'm a big fan of .NET. I'm working with the .NET Products Science Framework 2.0. So for me it's already 10 releases of C#, multiple releases of .NET itself, and I'm still using it for from day to day for my personal projects, from gaming to any other usage you may just imagine. So let's go. What's new in .NET 8? First of all, we're gonna talk about things like support terms, about performance improvements. I'm gonna talk a lot about performance improvements because this release is really huge, and the stuff that Microsoft brings to us, it deserves a really huge attention. Then we're gonna cover some part for dynamic PGO, native AOT, and slightly touch the surface of features across the whole .NET platform, and a bit stuff regarding containers. So let's go first about support terms. So this is 8th release of .NET Core. Now it's called just .NET 8, and it would be supported for next 3 years ahead. Next release, next LTS release, is planned only for 25, and right now you have half year to migrate from .NET 7 or 1 year for migrate from .NET 6. And I really will encourage you to move this, to migrate faster, because all benefits will provide you a lot of saving, for example. So let's go. Regarding improvements of performance. In latest version of .NET, 1250 and even more patches are designated only for performance. In previous version it was 1000 or even just 500 for .NET 7 and .NET 6 correspondingly. So I'm gonna talk about code improvements, the things that happen underneath that nobody wanna look at, but we all benefit from those changes. For example, things like collections, you are using them in your daily practice all over the places. And now, for example, creation of the empty collection now doesn't cost anything. It does not allocate any memory. Whenever you are trying to, let's say, to query something using link queue and convert it to list, this information now go directly to the inner span, which save you some allocation and boost your performance in ordinary operation. There is a lot of improvements like on basic layer. Regarding most noticeable thing, let's say the main focus for .NET team to improve since a few latest releases. They eagerly wanna to use as much as possible vectorization. For one of you who are not familiar with vectorization, or how it's called properly, single instruction, multiple data. It's an idea where you can send just one instruction, feed it with multiple data points, and do stuff like in one instruction on CPU, instead of doing it repeatedly one by one. For example, for things like, .NET promises you whenever you create a new array, for example, that all value of those array are zeroed initially. And you may imagine, like now you can just request empty array, and using vectorization, all queries to this array, all zeroing stuff will be done faster. By faster, I mean like 10x performance on those basic stuff. Also, whenever we're talking about performance consists of different stuff. For example, change of the vision, let's say change of priority. Previously, for many years, .NET mainly depend on framework-dependent distribution model. So you assume that .NET installed on target machine and just supply it with a big piece of code. But it's not always good whenever you have like systems that, for example, for containerization or for things that require you more work to be done ahead of time, like mobile devices or other things that require additional security and where JIT is not possible. Let's go further. So one of the feature of JIT called dynamic PGRO. PGRO stands for profile guided optimization. Let me just recap here a bit. So each time you launch your application, JIT compile your IL code into exact instruction for specific CPU. But it's additional round of compilation, and it requires some resources, and it influences into application launch time. Yet you should somehow balance it in order to speed up launch time, in order to speed up execution. And for many years, there were only one single JIT execution cycle during the startup. But it changed in .NET Core with introduction of tiering. Whenever we can launch multiple way of optimization, which each new layer already benefit from previous launch or previous improvements. So for one of the example, constant folding, for example. Whenever you launch your application, initially you don't know what's go into read-only field while it's not yet optimized. But a few seconds later, you know that this field contains some specific data or some Boolean. Based on this Boolean, you may cut the whole, let's say, part of execution. Let's say the huge amount of code, maybe just throw it away, which will give you some performance boost. According to Microsoft, they tested 100,000 of different projects on GitHub in order to understand will it be beneficial in this large scale. And like average temperature for the hospital was like plus 15% boost for all application. Just free improvements for nothing. You should keep in mind that it's like always depends. It depends on your application, how you use it, how user use them. But introduction of dynamic PGO give you an ability to launch multi-layer improvements over the time and for end users. So those end users use your product differently. But at the same time, they may benefit from their own usage, their specific usage. Previously, it was only possible to do some preparation of the data statically before embedded into executable, but your QA team may not imagine how end user can use it. So let's go further. Regarding things that was requested from the other team, other approaches, other view on how you deploy your application. Native AOT stands for native ahead of time completion. In this process, you deploy just one single executable, which was pre-built for a specific target platform. So you have to know which platform you're gonna use, and you lose some beneficial thing from dynamic PGO that I mentioned just a few seconds ago. But at the same time, native AOT and the compiler use mostly, let's say, up to 80% of the same technique that was used in dynamic PGO, where it's applicable. There is some limitation, not all third-party libraries supported, not all part of .NET supported. You're gonna see some details, some slides with some real examples later on today from another speaker. So let's move further. Regarding overall improvements across all the .NET. .NET is a huge platform designated to multiple form factors, and I choose only, let's say, only stuff that maybe not cover all your use cases, but would be beneficial for you most likely, I would say. Like in our day-to-day job, most of you use JSON serialization in any form, and from .NET 8, you have like nice snake case, support kebab case, any way of JSON you prefer. Also, in order to support those native AOT, Microsoft do a switch from initially reflection-based generation of JSON into ahead of time completion. And starting .NET 8, this is like default behavior. From other useful things is like deserialization into read-only properties, streaming data, streaming JSON data. There will be also part regarding new metrics API. It will be covered by another speaker today. Another interesting thing is time abstraction. For many years, different company, different developers trying to solve the same issue: how to test procedures when you're using some time, like time-dependent code. And this is one of the way of solution provided by Microsoft is abstract class time provider with iTimer interface for things that depends on the range or time frame. Another, 1 second, please. Another interesting topic is different kind of string. As you all know, .NET use UTF-16 for string underneath, but all over the places in the web, for now, the most popular format is UTF-8, which twice less than UTF-16 in storage size. In order to speed up things that are related into conversion, like for example, you have you're preparing some JSON with some values in it. Right now, in previous version of .NET, you have to firstly create some strings and then convert the string into from UTF-16 back to UTF-8 before you sending them to for the clients. Now, with introduction of UTF-8 span formattable, in multiple places for all native type, you can skip this step, and you immediately send data in UTF-8 format if it needed for you. Some nice improvement for VPF. Finally, I'm personally waiting this for a long term. Really, hardware acceleration in RDP session, and different specific type that I encourage you to use, like frozen collection, frozen dictionary, frozen set. They really easy to use. You just prepare some data and feed, let's say, frozen dictionary with those data, and then it optimizes it for read-only scenario. Whenever you don't expecting any changes, you will gain a performance boost. Also from .NET 8, there is new support for AVX 512 or 512-bit instruction. It's also reference to CIMD, single instruction multiple data, that I mentioned before, but with larger set of data. And most of current CPU supported already. So you just benefit from CPU you have underneath. Let's move further. It's definitely not all improvements in .NET. I'm just select some of them. So some improvements for the containers or container scenario, now you can push your container faster because some atomacy in operation was added. Additional support for Harbor, Artifactory, Podman. Now all the containers contain Debian 12, like a base image, and for security reason also, right now there is like non-root default user. And one additional thing from the garbage collector world, I put it here because it's really connected to the container usage. Now you can dynamically ask garbage collector to change their current limit. Previously, it was possible only at startup time, so let's say environment configuration. And now you can just change this limit, call refresh memory limit, and if everything goes fine, they already mentioned that it may not work from the first time if garbage collector cannot compact data right now, but it can later on. So this is useful for the scenarios when you have, let's say, peak user amount, you increase your memory consumption multiple times, and then there is no traffic, you can scale down easily. Now it's possible from the API itself. Okay, let's move further to the C# part. New release of C# 12, and what it brings for us, like most popular feature is a primary constructor, also collection expression, some optional parameters in Lambda, and alias for any type. So there will be some code slides with basic stuff like for C# 12, and in C# 12 you can easily create some class, inject logger for it, and it would take up to, let's say, 10 line of the code. In a few versions ago, Microsoft introduced the feature primary constructor for records, and now they expanded into class and structure. So now in C# 12 you can do the same with just 4 lines of code. Now for the first example, it's initialization. it would be underneath converted into really the same code you saw here. For the second example, things are a bit different because here there is usage of logger inside of the method, and underneath it, compiler create you hidden field with unspeakable name, and lifetime of the logger would be extended. But with grid feature come grid responsibility. And so we go. So first of all, other constructors will require you first call primary constructor. But you cannot call parameters of the primary constructor with this, because this logger is not part of the class. It's something outside of the class. You may call it like with the logger. In my example, it's just a copy of the logger. And also, most important thing here, you can rewrite it anytime. Please don't do this. Let's move further. Another cool feature is collection expression. Here, version of prior C#12. You may note it's collection initializer. The same or similar syntax. Whenever you create some arrays, you can fill up some list. Second instruction would be expanded underneath into multiple call of add method on the list. So it's like 5 instructions just to fill in the list. But now in C#12 you can do this with slightly different braces. It looks much clearer, and you can initialize a lot of different things. Like, for example, I read only list with just 2 symbols. Create dictionary with 2 symbols. If you can do it shorter, I'm willing to see it. So this look nice. And in addition to collection expression, there is new operator, just 2-dot spread operator, which allow you to combine different, let's say, arrays into parts, some collection into parts, and this construction will benefit if it's ahead, if it know what the size would be. You also will receive performance boost. But maybe for some of you, these 2 dots look really familiar. Maybe you saw it previously, something like that, for example. So this is example how you should not write the code. Like the first 2 dot is a spread operator, the second 2 dot is a range operator. The same braces all over the place. So it looks familiar, but it's meaning different things. Now in C#. Welcome. So another nice feature is default parameters in Lambda. You can say prepend some Lambda with some default value. It will be beneficial in some scenarios, like configuration and something other. But at the same time, you should know that currently, whenever you gonna create or reuse this feature, underneath there will be custom delegate instead of function or action like it was before. So some cases, some usage may be broken if you start using default parameters. And another small but sometimes useful readability feature is alias, which let's say, they just remove some limitation on using, and now you can use a lot more types and rename them. Like in older days when you can, let's say, set true to false in C++ code and wish happy debugging for new developers. So some useful link for you, just as an artifact, especially the last one, like foundational C# certification, which is free, and you will receive something like that. This one from Scott Hanselman. and you have to pass this Microsoft exam. And I believe that's it for me. If you have any question for me, I'm ready to answer you.
Thank you, Andrew. We have one question.
Thank you. Can you go back to container slide? Thanks. Oh, yeah. Yeah, you talked about garbage collector.
Yep.
In container scenario. Previously in .NET Framework, it was the problem with garbage collector because it was automatically compiled as a server system, server image or server, so utilizing or expecting several cores or several threads to run, and you especially needed to ask compiler to compile for one processor. Well, typically a container runs on one core, yeah. So my question is, in .NET 8, it is automatically happening to understand that .NET 8 understands that it's running inside the container, or you still need to add some magic commands to the compiler? Thank you.
Okay, first of all, there is just a reminder that there is two types of garbage collector supported in .NET, workstation and server. I'm personally faced an issue whenever you launch application in the container. It sometimes doesn't feel good in terms of memory limitation. I faced such issue before, and I hope I didn't try it yet, unfortunately, that this ability to dynamically resize it will fix it. Like, you're gonna try.
Okay, obviously I will try.
Like, unfortunately, there is really a lot of good feature, but let's say our product that I'm working on, it's not yet moving to .NET 8. It's planned, but
Obviously, no, not every Yeah, thank you. So I just wanted to say that when you say move to .NET 8, it's not all possible now for move. Third-party libraries are not moved to .NET 8. So basically, you are not, typically you are not programming, from the scratch. You're using some third-party libraries, some other frameworks or so, and you need to wait. Okay, thank you.
thank you, Tom.
So the comment regarding the dependent libraries, so .NET is like very highly compatible, and if you, let's say, have a library based on .NET 6, you can easily use it with .NET 8. So, I mean, yeah, definitely you need to convince like your project management or architects to invest into the upgrade, but that's the different story.
One more question from our viewers online, Andrew. So Alexander asks, what is the difference between I-read-only dictionary and frozen dictionary?
So first of all, it's different interfaces and they have different purpose. I read only, it just mentions that data in the dictionary are not supposed to be overwritten or added, removed, and so you cannot change the collection. I-frozen dictionary contain underneath additional improvements that was built with the mind that you never change it. So you can compact it in the memory, you can put it into one frame, and you can, by putting them into closer space, you would need less instruction to reach it in memory, and it would work faster, something like that.
Thank you. Any questions?
Well, just curious about array initialization. Is this add instruction underneath also, or is somehow different for the new syntax?
So, with the new syntax, what they done underneath, they change the way how you initially create underlying, let's say, arrays for stuff like, for example, for list T. if previously list contained some default array with a default size like 4 elements. And now it does not contain anything from the start, and whenever you create or add data to it, if compiler have any knowledge about what would be the size of those data, you can initially initialize underlying array with the proper size, and it would be faster than iteratively add one, and so on. So from user perspective, you don't change anything. You just gain some performance of it. But underneath, it was changed.
Anybody else would like to ask Andrew?
Thanks. You just show us that about this AOT performance increase, and does it mean that we will be able to replace, for example, Pythons to write functions, lambdas, etc., and expecting the same hot start time for these things? Thanks.
Yeah, I can answer on that question, but during my presentation, I'll talk about that.
Oh, okay. All right, thanks.
Like, unfortunately, we have to split this apart. Some data, some numbers will be in from next speaker, okay? Because this feature is huge, and once again, it's just another way how you can pre-build your application. You don't lose all, let's say, whole functionality from the platform itself. You just lose something, things like JIT. And you maybe lose some performance. It depends, once again. It depends on your usage of reflection or other, let's say, huge, important stuff based on reflection, which you may use. This is why it took like 3 releases for .NET just to move it to the public. And it's still ongoing process. Things like MAUI, VPF, it still doesn't support it because they heavily rely on reflection.
Thank you, Andrew. I would like to ask another presenter. Alexei, please.
Okay, can you hear me? Yeah, now it's good. Animation is not very fluent for some reasons. Okay. Yeah, let's make a start and let's talk a little bit about what's new in ESP.NET Core part. So ESP.NET Core is like a crucial part of .NET ecosystem, and this is probably vast majority of us are going to use in our production applications. Generally speaking, I think this time ASP.NET Core got probably one of the largest increments in many areas. It got a lot of new APIs, a lot of optimizations and so on. So let's just briefly take a look what's going on there. What should we expect once we do the upgrade to .NET 8? So just really briefly, who am I? My name is Alexey Khashklep. I'm a delivery manager working at EPAM for 10 years. And my areas of interests, of course, .NET, ASP.NET Core, C#, and AWS Cloud. So that's enough about me. Now let's concentrate on really interesting topics, which are ASP.NET Core. So as I've mentioned, ASP.NET Core got a huge increment from different angles, but I'm going to focus mostly like on 4 pillars, which are again performance improvements. I know Andrea talked a lot about that, and I'm going to talk about that from the ASP.NET Core perspective as well. I'm also going to talk about native IoT. Andrew only touched, but I'll show how native IoT became applicable for ASP.NET Core workloads. And I also would like to talk about Blazor. I know this is not very popular framework right now in user interface development world. I hope that starting from .NET 8 we will start considering it as a production-ready framework. And then I'm going to talk about .NET Aspire, which is a kind of new beast in our ecosystem. Let's see what is that. So what Microsoft is proposing us to use for building distributed applications. Okay, so let's make a start. Let's take a look at the performance. So what I really like is that Microsoft started treating performance as a feature. So they started investing into the performance a lot for like maybe 5 years ago. So each and new release that they do for .NET got a lot of performance benefits, optimizations. Okay, just a moment. Yeah, so each and every release of .NET got a lot of performance optimizations, and in this time in ASP.NET Core, we also have some numbers. So what are they? So according to Microsoft, just some story here. Microsoft is using Tech and Power benchmarks in order to measure the performance of the ASP.NET Core. Tech and Power is a company that actually drives all these initiatives to compare different web frameworks and their capabilities. So Microsoft actually in a partnership, and they use it to measure the upgrades that they made to ASP.NET Core here as well. And they measure the performance from the different angles. For example, they measure the JSON scenario. This is when the request is coming to your API. Serialization, deserialization is happening and returning to the caller. Or they have like fortunes benchmark. This is like more closer to real life scenario. When the request is coming to your API, the API logic does some query to the database and returns the data from the database. So in both these scenarios, ASP.NET Core got performance improvements, and in JSON, as you can see, according to Microsoft, it's 18% of the improvements and 24% improvements for fortunes scenario, which is a kind of cool. So we just upgraded our ASP.NET Core application from, let's say, from 7th, or if it's from 6th version, then probably it would be even higher, because it's 2 versions of .NET increment, and we automatically got like, let's say, 20% of the performance. That's cool. That's really cool. I don't know. So that should convince you to start investing into the upgrade. So how good is .NET comparing to other frameworks? So again, we can use here Tech and Power benchmark statistics, and this is for 2023 year, and here we can see that .NET is in the top 20 frameworks, web frameworks from the performance perspective. This is for fortunes test, which is, as I've mentioned, a kind of real life scenario scenario that involves database call. So as you can see, ASP.NET Core with ADONET Postgres database is on a 16th place, which is good, but yeah, there is a room for improvements, obviously. But if you take a look at other frameworks at the competitors, not too many of them are like real frameworks. They were mostly built in order to compete in these Tech Empower benchmarks, but we know that ASP.NET Core is a production-ready framework with a lot of capabilities that we can use in production. So I think even 16th place is a very good result. What is really interesting that if you take a look at this table for 2022, we were even higher. So we were on the 9th place. For some reasons, we dropped to 16th. And if you take a look at the score, it became lower. So I'm not sure how Microsoft got this then 24 and 18% of the improvements. If we compare what we have on Tech Empower benchmark websites, we will see that it seems like the score is lower. So the only thoughts that came to my mind, probably this table they got from their internal tests. This is not what Tech Empower got. So I believe Microsoft ran the same tests on their own infrastructure and got these benefits. But when they submitted ASP.NET Core for tests on Tech Empower servers, they got lower results. That's interesting. So I'm not going to say that Microsoft is trying to cheat here. I still believe there is a performance benefit to upgrade to ASP.NET Core 8 from 7th version, and you will get this reasonable 20% of the improvements, because we know that they invested a lot in performance optimizations in core area. They also optimized Kestrel, core libs, JSON library, and if you don't do native IoT, then you will get dynamic PGO with this tired compilation that Andrew described very well. So I think just by upgrading of your ASP.NET Core application to the .NET 8th version and getting reasonable 20% of the improvements, that's a good justification to start investing, at least start investing into the moving to .NET 8. Right, so that's enough about the performance. Now let's talk a little bit about a feature that is called native ahead of time compilation, or AOT. So this is not a new feature. It appeared in the previous versions, but starting from .NET 8, Microsoft describes this as a thing that could be applicable for ASP.NET Core, and I'm going to talk very soon why this is important for ASP.NET Core scenario. So just in a few words, what is native IoT and how it works? So there is still C# code that is compiled into intermediate language during build time. So we have here Roslyn compiler that does this job. Then we have another tool chain that that compiles intermediate language into the native code after Roslyn does this compilation to the intermediate language. So this is happening during the publish, because probably you don't need native IoT during the debug. Well, you can, but why? So probably you need only you need to do this only publish time, and then your published application looks a little bit differently compared to what we had previously. So first of all, it has no JIT. So no JIT, no just-in-time compilation. So the application still has garbage collection, and it still has some kind of runtime. It's not like the same runtime, exactly the same runtime that we have in a non-IoT scenario, but it's still runtime. So we still can say that despite of the effect of compiling into the native code, it is still managed application. Also, it's a single file. It's streamed file, so its size is much lower compared to non-IoT scenario, and it is tightly coupled with the specific architecture and platform for which you are publishing your application. So, what are benefits? Why this is important for ASP.NET Core scenarios? So there are like three interesting benefits that we are getting by applying native IoT for our ASP.NET Core application. First of all, the resulting file is much lower, so I'll show some numbers. That's not probably the most fancy thing, but what I really like, for example, is that the reduced startup time. So it's because we do not have here JIT compilation anymore, so the application is ready to start like once you launch it. So there is no JIT, the startup is much faster. And also, as a rule, like natively compiled applications consume less memory. That means you have better scalability options. Let's say if you are using Kubernetes, so you will be able to place more nodes of your application in more instances of your application on a single node. So now let's talk about numbers. Okay, so what Microsoft shows us, like we have the following statistics. So Microsoft compiled one of their APIs that they tested without native IoT scenario, ran some tests and got the following results. So as you can see, published size is quite large. It's about 100 megabytes. Startup time is about 150 milliseconds, and requests per second, it's about 800,000 requests per second. So as you can see, there is a statistic for both Linux and Windows. What is interesting in startup time on Windows is 2 times slower, as well as requests per seconds are lower. So Linux is beaten. So .NET behaves on Linux better than on Windows. So then they applied native IoT compilation, ran the same tests, and got the following results. First of all, the published size, it's only 10 megabytes. It's 10 times lower comparing to a non-IoT scenario. Startup time was reduced almost 5 times, so it's about 30 milliseconds, which is really impressive. So the application started 5 times faster. We also could notice that requests per seconds were a little bit reduced, but comparing to 5 times better startup time, I think it's worth to sacrifice 10% of your requests per second. Well, of course, it depends on your scenarios. If startup is crucial for you, then native IoT is probably the way to go, one of the ways to go. Right, so does it mean that you should start immediately compile everything, try to compile your ASP.NET Core applications to native IoT? Unfortunately, not everything is simple. So native IoT currently doesn't support it it's not supported for everything. So Microsoft concentrated mostly on providing like the capabilities for the minimal APIs workload. So yeah, middlewares, gRPC, JWT authentication, authorization, and minimal API will work, but MVC, Web API, Blazor, Razor, SignalR, all these things just don't work because of the nature of the native IoT. So MVC is heavily based on the reflection, on dynamic generations probably. So all these workloads currently doesn't support it by native IoT. So what else is really important? So if your application have a third-party dependency that also is not compatible with native IoT, you will not be able to compile your application to native code as well. So, for example, if you are using Entity Framework, even with minimal API, which supports native IoT, then you will not be able to get natively compiled ASP.NET Core application because Entity Framework currently doesn't support native IoT. There are some micro ORMs already created that support native mode, but Entity Framework is not there yet. So there will be, my understanding, there will be a push from the Microsoft to the community to start upgrading their packages to support in some way, somehow, the native IoT mode. So that would unblock these packages to be used in these scenarios. So in order to start using native IoT, all that you need to do is to enable publish IoT flag in your CS Prosh file, or you can pass this during the publish command in your CLI. There are also other options available for publishing. Some of them quite controversial. We have here a self-contained flag, we have trimmed, ready to run flag, single file, and I'm really interested what would be, let's say, if you publish AOT and ready to run, or pass it ready to run files. So what would happen? So I think here Microsoft should like revise these flags and make them not as controversial comparing to each other. Just briefly recap. So we've talked about native IoT. So where we could apply this capability. So I think this is really interesting feature if you are building some applications that require fast startup, for example, Lambdas or Azure functions, or maybe you are building something on top of your Kubernetes that requires really rapid scale up. If you are building application with low memory consumption, this is also a pretty attractive option. And also you can consider native IoT if you are trying to build like self-contained small command line interface utilities. Cool. So that was like that was native IoT feature. Now let's talk about Blazor. And first of all, I would like to ask anyone. So, do you have Blazor in production? Did you try Blazor? So nobody. So for online audience, please put some comments if you started using Blazor in production. So I know Blazor is a little bit strange project. Microsoft presented it like maybe 3 years ago, but seems like community is not going to. So its community hasn't adopted it yet, and the reason was obvious. So when you look at Blazor, it doesn't look like something really reliable, something web friendly. And in .NET 8, Microsoft really invested a lot in making Blazor look like a really web friendly framework that you probably could consider for using in production as a framework that you would like to use for building your web applications. So Blazor got a really huge update in .NET 8. So Microsoft invested in Blazor in like 3 different areas. So the first area is, as I've mentioned, so they tried to make Blazor something that could be considered as a full stack web UI framework. Especially I would like to highlight, and I'm going to talk about that later, I would like to highlight static server-side rendering capability. And also the capability to select the render mode at the runtime for different components and for different pages. So I'm going to talk about that just in a couple minutes. So another area when Microsoft invested in Blazor, it's just like generic enhancements. And here I'd like to highlight quick grid component. So this is not a surprise. If you are building a business level application, then you probably need some kind of table capability. So you probably would like to have a table, have some sorting there, pagination, and so on. So now you have this out of the box with Blazor, which makes like kind of perfect candidate for if you need to craft a small application with some tables, sorting, I don't know, something complicated to present like to the business. And the third area is the runtime improvements in WebAssembly world. So here happen few interesting things happen. First of all, Microsoft introduced jitterpreter capability. Very funny name, I think. But what is hidden under the hood? So previously, your Blazor applications were compiled into the intermediate language or in a WebAssembly code. So there was no options to like use combined versions of having like both intermediate language or WebAssembly. And when you run your application, it was like run as a native WebAssembly code, or it was run as a intermediate language that was interpreted by the Blazor runtime. So now we have jitterpreter that could compile some of your code right on the fly into the WebAssembly, and some of the code will be still interpreted. So that's why the name is is such a strange. So what else I would like to highlight here is WebSeal packaging. So before .NET 8, when you compile your Blazor application, then you start loading it into the browser, you will see that DLLs are loaded right into the browser, which is nasty, you know. So DLLs is not something that I would like to see in my browser to be loaded. So now there is a capability to package your .NET code into web-friendly package, which is called WebSeal. So yeah, huge improvements, massive increments. And now I would like just to highlight this probably the most important, the most crucial feature, which is server static site rendering. So as I've mentioned, Blazor it never looked like a native web framework, because from the beginning it had like two options. It was able to work as a server Blazor with a server Blazor mode when this is when you start requesting your Blazor application. You are receiving some initial HTML and JavaScript and the Blazor runtime code, and then once you start interacting with the application, the JavaScript collects all the events, sends the events to the server through the WebSockets. Server renders the differences in the HTML and returns these differences to the browser, and then browser renders these diffs. So that's not like typical web applications behave, right? So there was another mode, which is like pure client-side mode. This is when your application was compiled in a WebAssembly code. You load all these nasty DLLs, and everything is rendered in a browser through the Blazor runtime. Again, this is not a very web-friendly way of building web applications. So now we have in .NET 8 we have a third mode, which is called static server-side rendering. So this time, if you do the request from your browser to your web application, to your Blazor web application, all the HTML is rendered on the server side and returned to your browser as a pure HTML, JavaScript, CSS code, immediately ready to be rendered by your browser. So yeah, that's cool. This is how web applications should look like. So what are the drawbacks then? Why they didn't do that from the beginning? So the problem with static server-side rendering is that you are losing all this interactivity, all these interactive capabilities. For example, when you do some drag and drops or sorting, so pure HTML just can't do this nice animations, nice interactivities, because it's just a statically rendered page. So what is the solution then here? So in order to address that type of issue, Microsoft also allowed you to control the interactivity mode. So like before .NET 8, and well, you still can do that. So there was a capability to turn on server rendering or WebAssembly rendering. This is what I just described, and that was applicable for the whole project. So now you can create a project, enable static server-side rendering, and then enable interactivity per page or per component. So let's say you know that for this page there are a lot of interactive components, yeah? So you would like this page to behave like more user-friendly, to have more animations, like all these drag and drop capabilities, pop-ups, and so on and so forth. So you can enable for a particular page a particular way of interactivity, server rendering interactivity or WebAssembly interactivity, or you can choose even automatic mode. This is in this way you will rely on the Blazor choice. It will do this. It will choose WebAssembly or server mode depending on the whether the Blazor runtime is cached or not. So that's kind of cool, and that solves the problem with static server-side rendering. again, just to recap, so Blazor in .NET 8 got a massive increment from the API's perspective, from the internals perspective. So we have now quick grid control. We have this nice jitter printer that allows your code to be run faster. We have new static server-side rendering mode, and we have now capability to control interactivity per page or per component. And I hope that starting from .NET 8, more people will consider Blazor as a framework for building their next UI applications for their clients. Because I personally think that Blazor is a really nice technology. And now let's move on to the .NET Aspire, which is a new animal in the .NET world. So what is .NET Aspire? According to Microsoft, .NET Aspire is a cloud-ready stack for building observable, production-ready distributed applications. So, which is kind of very generic statement. So, what is hidden behind that, and what the problem they tried to solve with .NET Aspire? Yeah, by the way, I forgot to say that the .NET Aspire previously was like, it's renamed. So previously they named it as a Project TIE, so now it's .NET Aspire. If you heard about .NET TIE, then you probably know what is that. So the idea of .NET Aspire is the following. So imagine you are building microservice-oriented applications. So you have a lot of microservices that needs to communicate with each other. You have some third-party dependencies. Let's say you have databases or message brokers. So you need somehow to orchestrate all these components, microservices, and third-party dependencies. So what Microsoft suggests you to do with .NET Aspire. So you can create a special project, a special .NET Aspire project, and you can, using just C# code, you can express all these dependencies. You can put all the interconnections between services. You can add additional dependencies. Let's say you need a database. You can then you can also add as a dependency the database here, and then just with a one click you can run your whole application, whole system with all these microservices and with all these dependencies. So if you, let's say, need a particular database or RabbitMQ or Postgres, then you can add additional NuGet package to your project. You'll be able then to use this nice fluent builder syntaxes in order to configure let's say Postgres dependency for your microservices and put it as a dependency in this C# configuration file. And once you run your system, you will get automatically all these dashboards, structured logs, metrics, traces. That all these things look quite nice all together. I'll show you in a minute. So just really briefly. So right now I'm going to show some small demo that would include like this eShop application functionality. So this is from Microsoft samples. As you can see, there are like a bunch of microservices, some user interfaces, databases, message queues. So all these things I'll try to wake up just by running all these things through the project, through the .NET Aspire. Just a moment, I'm going to switch to my Visual Studio. Okay, so let me check if you can see. Yeah, you can see. So this is the whole solution. As you can see, there are a lot of projects here, and there is a special app host project. And here, right in the program CS, we can see all the configuration for .NET Aspire. We can see this builder syntax. We are adding here all the databases that we need. We are configuring our services, their interdependencies between each other. And now all that I need to do in order to run this, I need to press Ctrl F5. So as you can see, .NET Aspire run the dashboard on this URL. So one second, I'm going to copy paste the URL and navigate to it. Just wanted to show you how it looked like. So this is the .NET Aspire dashboard. You can see all the services are here. We can view their logs. As you can see, there are some errors because probably of the container start. So let's take a look. So we have here containers, event bus. So it's starting. Same for Postgre. It started. Okay, so it created some databases. Now I can press on the link to web application. So, by the way, this application is a Blazor application with a server static site rendering enabled. So I can choose a particular item. I can log in. This is very secure application, right? With the password on the login screen. So I'm going to do some interactivity to show you how structured logs are working. With just one hand, it's not very easy to copy the password. Okay. So I've just logged in to the shopping bag. Now go to the shopping bag. Again, this this application is pure Blazor static application. Checkout, place an order. So now if I go back to this dashboard and open, let's say, traces, I'll see some interactivities. So for example, how web application interacted with the card API. So I can expand and see how the request went through all the microservices. So that looks kind of cool, right? So that's all for free. Everything all these dashboards, all these logs I got for free just by using this .NET Aspire project. So let's get back to the presentation. So I hope you were really impressed with the .NET Aspire demo. Just before I finish up, so once again, so .NET 8 was a huge release, and and the ASP.NET Core got a lot of improvements in different areas. Just to give you some ideas of what you can find in ASP.NET Core 8. So, for example, my favorites are iException handler interface. So with this interface, you can easily control the exception handling for a particular types of the exceptions. Really nice and convenient way. Microsoft Extensions Resilience package. This is the package that is closely integrated with the Poly library that is very famous. So with this package now you can easily add retry, repeat, circuit breaker, all these nice reliable patterns to your HTTP communications, or another nice feature which is road tooling and endpoints explorer. This is a Visual Studio thing that allows you to browse all your endpoints. It also highlights all the issues in your routing configurations. Looks very cool. You can also configure particular HTTP requests and test your APIs right from the Visual Studio. Okay, so just summary. That was a really huge API increment for ASP.NET Core. So in order to cover everything, I mean, probably we need just maybe 5 or 6 hours only for going through the APIs. In ASP.NET Core, we was just by upgrading to .NET 8 version. Microsoft promised us approximately 20% of the improvements depending on the scenarios, but I mean 20% is quite good number. We also got native AOT scenario applicable for ASP.NET Core. Native AOT allows us to build applications that require fast startup and small footprints. Also, Blazor got a huge increment, huge update. So Microsoft is trying to make Blazor a web stack that we can consider for production usage for building our next user interfaces. And we also got .NET Aspire, the toolset that should simplify our life when we are building distributed applications and when we need resiliency, observability, and so on and so forth. Yeah, by the way, I forgot to mention .NET Aspire is still in preview, so it's not officially released yet. So a few links, we'll definitely share them. And that's it. I'm ready to answer on your questions.
I have a simple question regarding the Aspire dashboard.
Mhm.
Do you have endpoint testing similar to Swagger or something like that?
You do not have it in Aspire, but I can show where you have it. You have it right now, right in the Visual Studio. So if you upgrade to the latest version of Visual Studio, you can go to the View, Other Windows, and here you will see Endpoints Explorer, this one. So it's already here for me. So it looks like that. So it automatically detected all the endpoints in all the APIs. So for example, let's say I would like to test these items. If I do double press, so 1 second. If I double press, so it should open the HTTP file. I'm not okay. Probably I need to generate request. Yeah, I need to select generate request, and now you can see here I can specify the request. So this is a special file type. It's called HTTP. It has like a special syntax. It's similar to curl or so. It's quite easy to learn, and here you can put all your tests and test your APIs right from the Visual Studio. It's very similar to Swagger experience, right?
Yeah, it might be, but I don't see like stuff like body types to pass raw JSON or something like that. It's a bit more like code-like.
Yeah, but once you can, you write all these requests here, you can reuse them with this. While in a Swagger, you will have to click again and again. So this is like
that's a lot better. This
quite convenient way as well. So I personally like Swagger, but this one seems very interesting to me.
Okay.
Thank you for the presentation. Just your opinion on the future of Blazor. And
yeah, that's a good question. So for me, Blazor looks like a really attractive technology, and I really want people to start using it in production. But I understand that we have really strong competitors like React or Angular or other like more traditional frameworks. Yeah. So I think even today, even before .NET 8, Blazor had some area when it nicely works. For example, on my project where I am working right now, I used Blazor several times to build like fast, simple applications to present really quickly some data to the customer. So, for example, I put there some tables, so it was like really fast way to develop simple applications with like controls like tables, grids, or so. For internal applications, I think even today Blazor is a nice choice because almost any .NET engineer can dive into the Blazor for like day or two and then build quite nicely looking applications that like has considerably good quality and functionality. So the future is unknown to
yeah,
but I hope it will be bright.
Assuming you are Satya Nadella, CEO of Microsoft, would you keep investing into that?
So I don't think that Blazor is like a strategic direction for Microsoft. So .NET team is investing into Blazor for many years already, and I think like this .NET 8 increment that we got, I mean, that makes Blazor much more attractive because of this server static site rendering capability.
Thank you.
We have a couple more questions from online viewers. Alexei, so first comes from the Maxim. Maxim asks, is Blazor easy to debug? I always thought frameworks that mix markup with logic were hard to debug. Wondering if Blazor is better in this perspective.
Yeah, so if you take a look at release notes, since the first release of Blazor, each new release, you will find that hot reload is improved, reload is improved. So this time they also mentioned that hot reload is improved. So probably it's even somewhere on my slides. I'm not going to try to, but they promised that this time they again improved hot reload, and that means if hot reload is working, because for me it didn't work few times when I tried. So if everything is working for you, so then you just run the Visual Studio, run Blazor application, and then you fix some code in your Visual Studio, and then you will see immediately reloaded version of your application in your browser. So the debugging experience and this reloading experience of new changes should be quite comfortable to work with. But the problem is that it didn't work for me when I tried, so I'm not sure what was the problem. So maybe in this release everything is better.
One more question. On the .NET Aspire architecture document, there was an icon for OpenAI. What is the usage of it in that sample?
In eShop that I showed, in this sample, Microsoft also, during the .NET Conf that happened in November, they showed also this sample, and they showed this chatbot capability when you open the chatbot window and ask this chatbot, hey, can you place for me some bags or some other items, and the chatbot started automatically searching for items that correlates with the request that you put into the chat, and then it suggested, hey, I found these items, what would you like to put? And so that what they showed. But because I didn't put any API keys, Azure API keys, because this chatbot is integrated with Azure AI, so it doesn't work for me. So if I let's say show you this window, it will just display the message that you didn't configure your Azure AI keys correctly. But the idea was, like in this demo, the idea was to show that it's really easy to build a chatbot capability that can add some items with whom you can speak and add some items and have like this this chatbot experience to order some things from the website.
Thank you for your presentation. It was really interesting, and thank you for your answers, Alexei.
Thanks.
And let's welcome our last presenter of tonight's Gintautas. So he will present on OpenTelemetry.
Make sure that you disable notifications. Expand the notification. Okay.
Yeah, we test. Let's have a 5 minutes break.
Sveiki. Does mic works? Okay, good. Sveiki, my name is Gintautas Mušketas. I'm lead software engineer here at IPAM Vilnius. So I've been in the industry for quite some time. We had the opportunity to work in multiple domains, such as parking management, finance, and e-commerce. So I had opportunities to touch multiple tools and frameworks, .NET including JavaScript, front-end and back-end, Python, Terraform. And today I'm gonna talk about OpenTelemetry in .NET. Okay, so we will briefly cover observability, what 3 pillars of observability are. So we'll look into what OpenTelemetry is, how OpenTelemetry is implemented in .NET, and we'll finish off with a demo how OpenTelemetry and .NET can solve real customers' observability challenges. So to begin with, we need to understand what observability is. The definition says, observability is a measure of how well you can understand and explain any state your system can get into, no matter how novel or bizarre it is, without needing to ship a new code. Well, to achieve that, we need to be able to ask any question without anticipating it or predicting it in advance. So in other words, we need to find unknown unknowns, okay? So observability is all about how we understand and interact with our complex systems. So in order to achieve that, we need first of all to define requirements for data structure. So data should be of arbitrary width, and this data collection should be mandatory. So it will allow us to analyze the system on a wide range of views. Okay. So metrics, structured logs, and traces are commonly referred as 3 pillars of observability. So let's cover each of those. So first of all, metrics. Metrics is essentially a measure of a system at a given point in time. So it has associated timestamp associated with it. It's essentially just a number. It can carry some additional attributes with it, or it may not carry anything at all. It is machine readable, and it's easy to analyze, and it's easy to predict. So structured logs, on the other hand, are a timestamped the textual data. They were designed to be human readable. They are mainly formatted as JSON objects. They can be context rich, meaning they can contain a lot of data around about the event, and they can be completely shallow. So by providing just some data about me here, if you are doing a debugging of sorts, right? So the nature of logs makes them a little bit trickier to handle with machines. So traces, on the other hand, are completely different things. So it is a recorded sequence of events to a particular operation or transaction in the system. They have 2 components. So one is the trace itself, is an observed execution as a whole, and the span, which is a unit of work. Together, they form somewhat called a span tree, which allows to understand how actually our system behaves. So each event is arbitrary width and of arbitrary length, and they have a start. They have such attributes assigned to them. So first, they have start and then end timestamps, and they also include trace ID, which is association to the root event, and a span ID, which is a unique event ID. So, as I mentioned, each span can have multiple other spans associated with it, which allows to track it. So those 2 IDs form a relation called the trace context, which can be carried over service boundaries. So there are multiple ways to define those IDs. However, one is well known, which is used by W3C standards, and it is called trace parent. So it uses 16 bytes for trace ID and 8 bytes for span. Okay, so let's look at what OpenTelemetry is. Well, OpenTelemetry is observability tool framework and toolkit. It is designed to manage telemetry data, which is logs, metrics, and traces. So it is vendor agnostic, so meaning it works with open source tools and also works with commercial tools alike. It is not a backend as in itself. So it rather focuses on actual telemetry data collecting and forwarding. So it is currently ranked second most popular cloud native foundation project. So if you haven't checked this, please go do. So and there are following components included in OpenTelemetry. So it is OpenTelemetry protocol, which defines the encoding of telemetry data. It is a request reply protocol based on gRPC and also supports HTTP 101 with protobus serialization. It is also load balanceable, so which is very important. So collector, which is actual telemetry data gathering application. Libraries, which enables you to instrument your code manually. Exporters, which is a plugins that allows you to export your telemetry data to particular backends. And automatic instrumentation, as the name implies, you can enable this OpenTelemetry in without the need of change of code. So OpenTelemetry in itself is organized around signals, which corresponds to observability pillars, traces, metrics, logs. So each signal has its own life cycle. So it is available. It evolves independently. So if you decide, for instance, to use only one of the signals, you can just use that and wait for another feature in the future. So one interesting addition to the generic pillars is the baggage, which is provided by OpenTelemetry. It allows you to propagate span-related context to a different span. This is really useful because spans after creation are immutable, so you cannot add anything to it. So the baggage allows you a unified way to push some additional data. For instance, you decide to push some order ID to different spans, right? And you need to associate that data. So one consideration. One important consideration to keep in mind is there is a security risk associated to this because baggage allows automatic propagation of that data associated with it, and since traces can leave service boundaries, some sensitive data can leave your security perimeter. Okay, so let's look at OpenTelemetry in .NET. So there is some packages that have been for a while, so called the classic packages. So iLogger does support automatic auto-instrumentation of code. So it is, I don't know, everyone uses, right? So there's not. And the other two pillars are supported by system diagnostic. Namespace. So the meter supports metrics, and activity source and activity do correspond to tracer, which is the term used in OpenTelemetry, and span, which is activity. So it is activity source is an actual implementation of tracer, and activity source is an actual implementation, and activity is an actual span, right? So the terminology is different just because .NET's implementation predates OpenTelemetry's terminology, so they decided to keep the same name for consistency. So one interesting thing, if you are developing, for instance, libraries, so it is enough for you to reference system diagnostics namespace, and automatic instrumentation will pick up and do the job for you. And if you are actually developing applications, so you need to reference OpenTelemetry libraries. So what is new in .NET 8? Okay, so two libraries are introduced. So one is extensions telemetry, and the other is telemetry abstractions. So telemetry in itself provides you feature-rich logging capabilities. It also adds some new metrics to do out of the box. And telemetry abstractions is just as it's supposed to be. It's a high-level telemetry at the telemetry primitives. So here we see layered architecture of OpenTelemetry in the .NET itself. So on the left side, where we see sources of telemetry data, iLogger, meter, and activity, which is captured by OpenTelemetry SDK, and then this data is forwarded to actual internal exporters, and in that and this is done, and this is data also forwarded to actual backends, which is Jagger, Zipkin, and Prometheus. Jagger is used for traces, I think, as I recall. Zipkin is definitely for traces, so Prometheus for metrics. Okay, so that is done with a theory. So now it is demo time. So this is actual customer use case, and we'll see how it can cover, how it can solve your observability challenges, right? So who is Dress Sharply? The Dress Sharply is a fashion retailer which generates over 90% of revenue from e-commerce. It is overhauling the digital customer experience through a class-leading e-commerce replatforming solution. You see, that is the text written by someone, right? Okay, let's look at the stack, right? So as is, the Dress Sharply uses the various versions of .NET, including .NET 8. Actually, I just double-checked, and it does use, which is amazing. Also, .NET Framework. They use ASP.NET Core Web APIs. They have a hybrid cloud based on AWS and some old legacy on-premise solutions. So they support multiple other stacks such as Node.js, Python, and other bunch. So, and they are currently facing some observability challenges. So, first of all, they have multiple APM tools, which means that their telemetry data is scattered over all over the place, and that means it is a little bit harder to see and observe your system as a whole. So the other one is multiple telemetry collecting implementation. So it's less of a problem at the moment, but it would be nice if you can unify that and minimize the effort, maintenance effort required, right? So what would they like to do? So as I said, they would like to unify and future-proof telemetry data collection, right? Consolidate APM tools, so meaning to decommission some of them if they don't need it. Introduce new observability tools on demand, which might end up as a leverage for some new contract negotiation. Support multi-stack, and minimize effort introducing telemetry on existing systems, right? So if we can do this without need of code change, that would be perfect. So let's look at the actual demo setup. So on the left side, so it is actually an asynchronous search, right? And on the left side we have Lambda, which will handle search query. This query will be passed through Confluent cloud-hosted Kafka to on-premise existing web API, right? Where data will be retrieved and forwarded back to the Lambda the same way it came. Okay, for simplicity reason, Lambda is actually changed to console application, but it doesn't really matter that much. However, it uses manual instrumentation. So it not only uses manual instrumentation of OpenTelemetry, but it also uses non-Microsoft Logger. So on the right side, which is called on-premise, so we have an auto-instrumented web API. We have an actual SQL server without any instrumentations added. and we'll see how it works. So what we will do, so we will gather telemetry data, which is metrics, traces, and logs. We will forward this to a centralized open telemetry collector, which already has pre-configured to industry-leading observability tools, which is Dynatrace and Datadog. Okay, so it's demo time. Give me one moment. So we are looking at the Datadog log explorer. We've already pre-generated data. So essentially, this is the outcome of the demo, right? And we, give me one moment. I'll just close that. Okay, so here we see a bunch of logs, and we want to understand how the search was performed, right? So we can start by picking up any log, and we can find attributes associated with it, meaning. Okay, meaning that none of this code was set up manually, right? So everything that you can see, all the attributes provided by OpenTelemetry out of the box. So we can see service name, we can see SDK version, we can see something about distro, right? We can see the actual trace and span IDs, container ID that it runs on, right? And we can see the associated span with it. So here we see the complete search execution between two different services that communicate over cloud-hosted Kafka. Now, nice thing about traces is that once you have associated context correctly, you not only see the logs associated with it, right? Here you go. You have associated span. You have associated trace between two different services, and all of that mess you can find out due to help of OpenTelemetry associated logs with it. If you look at those, you can see what was happening in the system while the search was performed. Okay. So here we have all the list, and the best part about it is that we have auto-generated map between two services, right? So imagine if you have multiple of those, even more, like this is only two. So if you have multiple components interacting, so you will have a huge visual picture how your data moves, right? And what may happen. So, yeah. The same view we can see in Dynatrace, right? It's a little bit different. It's actually the same trace. It just displayed slightly different, but you can see the same result. So it might be a little bit better and clear to understand. So we start from init search. We call then trigger search. We call trigger search, right? Looks like a real production code, yeah. So we see something about produce search results and something about master, which is unclear. And if we can pick up any of that spans and look into the details and see that this was actual database, right? Called. We can check. Okay, this one does not have logs associated, but if we look at another span, so we have logs associated, and we can double check the details of that. Okay, so if you look at the Dynatrace, it has slightly different map view. So you can see each service separately, but you still receive association between two services. Give me 1 second. Let me see. Yeah, so topology should be. Yeah, you see. This is the second service. Okay, so yeah, that's about it from the visual side. So now let's jump into the code, and I will show you how OpenTelemetry is implemented in the Web API. So as I said before, it uses automatic instrumentation. So essentially, what we need to do is just to do a multi-stage Docker build. in the first layer, we install OpenTelemetry auto instrumentation tools. Then we build and copy that necessary libraries into our runtime container. And just before we start our application, we need to enable auto instrumentation. So we just run a script which enables it, and we just start application. That's it. If you look at the Docker container, all the configuration is done fairly simple, simplistically. So everything is provided by environment variables, and everything works like magic. It's kind of like magic. Okay. So we can look at the actual code. So there is one line which is custom implementation. That's because at the time of writing this demo, Confluent Kafka client was not ready to support OpenTelemetry out of the box, so I had to do manual implementation. But that's a good example how we can just do real-time demos, right? So yeah. So if we look at the code, this is a Kafka consumer code. So we have to manually instrument the code. So to start activities, so we start one. Then we pass this activity ID through message through Kafka message onto the other side. That meaning onto the other server, right? And once it's actually retrieved on the other side, we just need to parse this trace parent context and associate it with an current activity. So this combines, finishes our trace. Okay. Now let's look at the actual manual instrumentation of console application. Right. So here we have a startup file which creates registers trace provider. It registers additional emitter provider because some sample of common custom metrics were introduced in here as well. It's not necessary, but you can. And also it uses a serial log with its own implementation of OpenTelemetry exporter, and it just does not use any iLogger abstraction over it. And as you can see, those two can communicate easily together, right? Yeah, the consumer part is pretty much the same. The exact copy of Web API is just starts activity, retrieves trace parent header associated with span, and that is it. Okay. So it is the demo is pretty much done. So now let's look at the outcomes of an actual demo. So by showing this demo to the customer, I was able to show how we can decouple APM tools from our infrastructure, because it's just as easy. It's essentially a configuration for an external, for a centralized OpenTelemetry collector, right? It allows easy introduction of new tools because majority of vendors nowadays do support OpenTelemetry out of the box. It unifies observability approaches, so you can actually gradually replace your existing telemetry data collection pipelines with a new improved solution. It supports multi and hybrid cloud solutions, right? So hybrid one is displayed, but multi one is not, because OpenTelemetry even supports .NET Framework 4.6, if I'm not mistaken. So yeah, and I said that's the .NET Framework is supported. Okay, so after seeing that, Dress sharply decided to go with OpenTelemetry, at least to start implementing it. Yeah, that is it. Thank you for your time. So if you have any questions.
Hello, thank you for your presentation. I have a question not related to OpenTelemetry, but maybe it's OpenTelemetry, about instrumentation in databases. For example, in SQL databases, Oracle, MS SQL, there is sometimes need to like have a telemetry or observability inside storage procedures, calling each other and passing the like span and trace ID. Have you met this like challenge for you in your projects?
No, actually no, because no, I haven't actually, but I had
Maybe you're aware of any solutions for that.
not that I can think of any. So if you wish, we can actually take this offline, you know, and discuss it. So these are my contacts, right? So ping me at any time.
Thank you. Okay.
Thank you for presentation. I have several questions. First of all, about instrumentation. Instrumentation is another layer, so it takes time. Yeah? And in production environment, when we have a huge amount of calls to functions, what is the possibility to configure online instrumentation? For example, say, I don't want to instrument every call. I want to instrument only 10% of a call. Do you have possibility to have a dynamic configuration? Let's say I want to instrument only calls what will took on some resource demand. Let's say the metric of CPU hits 80% when I want to instrument calls.
That is a very good question.
Yeah, I know.
But well, if we let's open the code and look at that. Okay, a little bit. So, yeah. So, OpenTelemetry allows us to capture specific attributes, right? So you can actually capture additional attributes. So there is a configuration possibility provided by, I think, app settings, if I'm not mistaken now. But yeah, I think in that level that you require, probably not, but you can definitely capture specific events. It's because think of this as logs, right? So you can configure ASP.NET, for instance, logging through app configuration, right? So it's similar. But I don't really know the level of detail configuration, to be fair.
Thank you, Gindodas. Thank you all of our presenters. So it's really interesting. So probably some of us or all of us will try to add it to our production environments. Maybe not tomorrow, but in upcoming weeks. So thank you for all for participating. Thank you guys online for joining. Please follow our .NET Pro community for more upcoming events. Ačiū.